Hi all. Hopefully you guys can hear me. I think I might have my audio a little loud. Sorry about that. Let me know if you all can hear me and see me. Yes, good. Yes, good. Oh my goodness. Hi, Jerry. Oh, thank you so much. We have a moderator in and Mike Richardson. Thank you, both you guys. Thank you so much. I am making these guys work really hard. Who gave the sun an energy drink? That's what I want to know, because the sun is just not stopping. It's like just on a caffeine high, and it just keeps firing stuff off like crazy. So looks like everybody can hopefully, yes, good. They can see and hear. Excellent. I see a lot of wonderful names and faces. For those of you who are Patreon, please put your stuff in the Patreon feed if you don't get me to see you in the chat, because you guys get priority. You're the whole reason why this kind of briefing is possible. So thank you very much, and everybody be very nice to Patreon people, because they make this possible when I do it publicly. Oh my goodness. Okay, so I was trying to get a a formal forecast done for everyone, and I just couldn't do it because there was just too many things happening, and it just kept happening. And so I finally just said, you know what, I have to give up the ghost and actually just go in and do another briefing. So that's what I'm going to do. No, I am not super well prepared. So because I'm just as like crazed as you guys are. I don't know if any of you know, but over the past basically just few hours, we actually do have a solar storm hitting. Is it one of the ones that was predicted to hit? I am not sure. If it is, it's early. But we have had so many solar storms being launched that are like kind of off to the left, or off to the east, or off to the west, that have almost grazed us and look like they could graze us, that this might actually be one of them. But wow, this one is fast. And so it slammed the earth quite hard. And I'll show it to you in just a sec. So, so I'll try to get through a lot of the information first, and then we can do a deeper dive, and I can do some Q&A afterwards. Okay, so let me just try to get through this data first. As a matter of fact, let me make sure you can see the date here down at the bottom, and I'll try not to stand over it completely. Actually, I'll stand on this side. Okay, so this thing, I'll have to probably wait for this thing to reset, because I've got this this SDO image from basically the starting around the 1st. And when it resets, we'll see several things happen. Okay, on the 1st, you actually have that region 2887 launching something. And at that same time, you actually, nearly at the same time, you have something launching up here. That's a filament eruption. And then right after that, you have this monster launch. Okay, so then, and then after that, I think this region launches again several more times. And then you'll get something that launches over here. So let's run by this one more time. Okay, if you're keeping count, that's like 5 different solar storm launches, all on the Earth-facing disk. Okay, there's only one model, and I'll show it to you, and it looks hilarious. It's the Mosswalk. They are the only ones brave enough to run Enlil with all of these monsters in there. How well it does with their observations, I'm not really sure, but okay, they're brave enough to run it. No one else does that. So let's wait for it to reset, and I'll try to put my fingers in the right place at the right time. Ready? Get set. Here we go. There, boom, there's one. Okay. Then we have this filament launching up here, which you can get right there. See it launch? Okay. Then we get, boom, this guy. Ready? Boom, right there. There's that one. And then there's something that happens down there, but look over here. I want to catch your eyes here. Watch this kind of soft filament kind of go whoosh. See that change right up there? And then, of course, this guy, region 2887, it's been firing like 2 or 3 different eruptions like all this time. Okay, so I don't know about you, but there's actually like 5 different eruptions that are occurring all the time, because this one, the one that launched here, the filament eruption that launched here, at the same time, you actually had an eruption from region 2887. So if I let it reset one more time, seriously, you just don't know where to put your eyes. I mean, you'd think we're at nearly solar maximum when the sun does this kind of stuff, but this is when it gets crazy. Okay, there was the first eruption. Now watch the filament, but then also watch region 2887. It also fires. So right there, boom, see that? It fired there when that launched. And then we got this one, and then we got one over here. Meanwhile, this guy down here, region 2887, is still firing, same time that this one launches stuff over here. So I don't know. I think it's 5, maybe 6, 7, something. So we've got a lot of coronal mass ejections, aka solar storms, launching right now. Only some of them are Earth directed. Okay, now I'm going to show you the same thing, but I'm going to show it to you in 304 angstroms so you can see the filaments, because they're a lot easier to see in this wavelength, right? This is the really dense material. So you can see kind of what some of the sources are as the sun lights up like a Christmas tree. We'll wait for it to reset. November 3rd goes to reset to the 1st. And really what I want to show you is so you'll see this region, that region launches, but what I want you to see is this filament over here. See that thing go? Right? Do you see that go? I kind of blocked it, sadly. But then there's this other filament over here. When you see that, they're kind of hard to see in 211, the pink sun, but you can watch this filament go here. And it kind of just disappears a little bit. That's how you know, okay, that one kind of whisked away. That filament structure, believe it or not, that lifted off that way, you can see it kind of dangling over here. It actually is connected all the way across in like a land bridge to this structure that finally lifts off there on the 3rd that you saw, on the 2nd that you see right there. And what ended up happening is that part of this structure ended up feeding some filament that's up here, about mid-disk. And this filament structure is still there. But that ended up feeding this filament, and then it fed down into here, and it became unstable. And between all the eruptions that are going on in 2887 and this region, it ended up just being too much for it. And so it launched. So we have I'll show you the coronagraphs. They're just dizzying because there's just stuff launching to the north, to the south, that then makes it look like a single halo. They're not, but okay, it's confusing. And it masks some of the other things. As a matter of fact, it masks some of the eruption from region 2891, which is this guy, right? I'm going to go here. So you can watch, there goes that little filament, and then shortly thereafter, you get this boom, right? Okay, that thing ends up lighting up like a Christmas tree. So there's just a lot of stuff to try to keep track of. And the Space Weather Prediction Centers all over the world, God bless them, but they can only do so much, right? Because we're just human. And so it's like, oh no, this one, no, wait, this one. Which one do we look at? How do we exclude this, that, and the other when we're just trying to single them out? Because remember, all of these structures as they get launched, right? It's like looking at my hands. Can you tell which hand is what? Kind of hard to, right? When it's all smashed into a single two-dimensional object, right? So that's what's happening, is that the poor Space Weather Prediction Center people and around the world, the scientists are literally trying to gauge what part of the junk that's coming off of the sun is part of what structure. And so when they get their speed measurements, it becomes a real challenge for them to try to take apart one structure from another and not include the analysis of something too fast, and saying, oh, that's part of this structure, when in actuality it's something behind it or something somewhere else. So it can be extremely challenging when the sun gets busy like this. Now, for those of you doom and gloom people, don't worry. None of these storms are Carrington class, okay? The fact that the sun is lighting off about 8 CMEs a day is not a problem, okay? This is normal. All right, this is just normal for active times. And as a matter of fact, as we get even closer to solar maximum, we're going to have this many solar storms being launched, but they're going to be more eruptive, right? They're going to be more like this eruption. When you see this puppy light up, there'll be a lot more big eruptions that look like this, right there, boom. Okay, so you're going to see a lot more of those types of things as we get closer to solar maximum. But again, please don't worry. Please, space weather is it's just like weather, right? Not every rainstorm is a hurricane. And for those people who are dealing with the fearmongers out there who keep saying, "Oh my goodness, how can you be so excited? These things are planet killers." They're not. Solar storms hit Earth all the time, and when we're close to solar maximum, for example, we get G2 level solar storms once or twice a month. Okay, we've been riding these storms out for millennia, and it's not the end of civilization, I promise you. So I mean, I've been fielding a lot of stuff on social media about people who are very nervous that these storms are horrible. They're not. They're rainstorms, guys. Some of them are a little bit worse than others, right? And as we become a spacefaring society, it becomes more important, granted. But they're not planet eaters. Don't let an astrophysicist talk about Alpha Ceti or some other, Antares or some other faraway star that was micronova, and then says, "Oh, wouldn't that be cool if it happened at our planet? Or I mean, in our solar system with our sun?" No, it wouldn't be. And don't worry about it. Our sun is middle-aged. Okay. It just wants to have its coffee in the morning, a clean commute to work, come home and not have the kids just yell at it all the time. All right. It's a middle-aged star. It's just kind of wants a quiet life at this point. I'm sorry, that was terrible, but I'm middle-aged. So, hey, I'm allowed. I'm a card-carrying member of that community. So, all right. So, let me talk about, let me stop this real fast, because what I'm going to do is I'm going to jump to the Coronagraph so you can see how much junk is actually coming toward Earth. So this was the first. Okay, this is November 1st. This is the Coronagraph from Earth. I'm only just going to look at LASCO coronagraphs for the moment. Okay, we don't have to look at stereo stuff as of yet. And the reason why is because I would just want to give you the Earth view, right? So what we're looking for are things that are going all the way around the sun. Now, what you're looking at, actually, well, these are the raw images here, the red ones. And of course, the sun has been occulted, right? It's covered, right? We're creating a false eclipse is what we do with these instruments in space. So that's why you can't see the sun, why it's blacked out. And we black it out beyond just the sun's disk, which is what you see here. We black out some of the really, really bright atmosphere because it overexposes the images. We find that we do better when we can see just the outer part of the sun's atmosphere. Okay, so that's what you're looking at here. These are difference images. So basically we take one image and then we take another image and we subtract them. And when we do that, we get highlights of the features, and they are either in black or white, depending upon where they are moving. Okay, whether something was there and now it's not, or something wasn't there and now it is, that dictates whether it was black, the region is black or white. Okay. But what it does is it allows you to highlight features that are a little bit tougher to see in the raw images. Okay, so I will talk only about the gray images. Okay, so actually I'm sorry, I should have, let me rewind. Okay, good. So if we start November 1st, okay, and I'm going to sit over these images so we can look at our difference images more easily. And if I play this, what we're looking for, it helps if I don't play it backwards, doesn't it? Yes. Okay, let's try forward. All right, hang on, let it reset. You can already see how much junk. Okay, so there's the first one. That's the first halo, kind of partial halo. Then there's nothing for a little while. And then there's something coming out slowly. And then there's something that comes out fast. And then another halo. Was that too fast for you? Was that like 4 CMEs really fast? Let's try that again. Let me slow it down. I'll wait for it to reset. Okay. So we started over. Here's the first halo. And it's kind of a partial halo. You can see it here. Okay. Now we wait for a little bit, then we start seeing something coming out up in the northwest, this way. Okay, then we start seeing something coming out. That was the filament eruption. There's the big eruption from 2887. And then, oh wait, no, this is the first, so it's not quite yet. But it was another filament eruption, and then you get a partial halo, then it resets. Let me start it again. Let me rewind. What I'm going to do is I'm going to pause every single time I see something useful. Okay, so there's the beginning. Okay, so this is the first partial halo. I can advance it just a little bit. Bing, bing, bing. So you can see this structure was not meant to hit Earth. Okay, this is might be the structure that's hitting Earth now, because this is a very fast structure. Okay, and it goes all the way around, right? And it goes past what we call central meridian. If I can get my hand in the right place, basically the center line here, right in the middle of this disk. Okay, this is the Earth-Sun line. All right. So if you draw that line straight down, I'm not very good at drawing a straight line, am I? Right, straight down to about here. This could be a buzz cut. This could be a grazing passage, because you see a little bit of junk, right, coming past the center line. Do you not? Just a little bit, right? So this is really one of those things where it's like, ooh, is this clipping Earth or is it missing Earth just barely? Because anything on this side, right, is going to potentially hit Earth. This side of middle. I'm sorry, my hand's back again, not in the right place. So anything on this side, could be hitting Earth. Okay, and that's obviously a rule of thumb. It's not obviously a give and take, because things get deflected one way or another. So this is an eruption that we couldn't rule out from region 2887 that could conceivably hit Earth. Now let's let that one go by. I guess I could just let it play for a moment. And then we see another one coming out to the north. I don't think that's not the filament eruption. I think that's a different eruption. And then, of course, good old region 2887 fires off again. Don't worry about the intensity, the color change here. This is just a gain change in the instrument itself. When it sees really bright things, just like a camera, its iris stops down, right? It has to change modes in order to get, a better resolution, right? It doesn't want to be saturated. So you're seeing some of these automatic gain changes. So there's essentially eruption number 2, but it makes it look, let me back up one. It makes it look like it's a big halo. This is not. These are likely 2 eruptions that probably won't hit Earth. This one may have a slight chance because once again, when you look at the center line, it's close. Not quite as close though, this time. Okay. Lots of stuff going on. Okay, so keep going. Whoop. No. Don't rewind. Oh, what did I do? Sorry, I had to start over, guys. I'm still going backwards. Stop going backwards. All right, so we're starting over. Okay, so again, that's the first one we saw. Okay, that's the first one that had a good chance of hitting us, just grazing us at least. Then we had 2 more. Come on. They're going slowly. There's one in the north, and then region 2887 fires again. Okay, it's not a partial halo. And then look, right after that, look at this puppy. And I'm going to just go. Yet again, we have another one coming out of this region. Now, I think one of these is far-sighted, so I have to be careful which one is which. But this is what people, the scientists in the space weather forecasting community have to deal with. Even if it's a far-sighted eruption, you still have to look at it, and you still have to sift through it because it still comes out in coronagraphs, and you can't tell, right? Unless you have something on the disk that actually tells you which direction it's going or what the source region was. Okay, so this is the end of November 1st. That's just one day. So let me go to November 2nd. And November 2nd will start with that same halo. Okay, just a little bit further out, but that's the same halo that we left with from November 1st. Okay, so it's the beginning of November 2nd. That's that same halo that we were just seeing evolving, just literally let out. And sure enough, this one looks like it could be Earth directed. This is the Earth directed one. Okay. Now, because I think this is where that's the big eruption from region 2887. Now, hopefully, this is going to, oh, good. Okay. There's the halo. And then once again, we'll have some set of stuff coming off on the west. Yeah, you see it up there. Okay. So I'll slow this down just a second. Let me get my bearings. All right. All this red stuff, this is the algorithm losing its mind. Don't worry, this is not real. So that red and blue stuff, those are markers that the algorithm is just completely losing its mind. It doesn't know what to do. It's probably being overwhelmed by the data here. All right, so let me get past this. Come on, there's the last ones. Okay, so again, this is the halo. That's the halo that we were seeing at the end of the first. And here I knew I couldn't let it run on its own. Here is the beginning of the halo from that region from 2891, that center disk whammy. Okay, and as you can begin to see on this halo, first of all, it's a bit northward, but it goes all the way around, and you'll see very quickly it goes all the way around the sun as it continues to evolve. See that? This is a full halo. Okay. So you can see even in the weakest areas, you can kind of see, hopefully that makes it out. You can make it out a little bit here. It kind of goes up this way and then back around. But this is a halo that goes all the way around the sun. Okay. This is region 2891. This is the direct hit. Okay. And now NASA, NOAA, and the MOSWAC have all modeled this one. This is the one that, if we're not careful when we look at it in the models, it looks like it overtakes and passes the one in front of it, which really can't happen. Okay. All I can do is sweep up the one in front of it. So that's the big monster that we're expecting. That's not the one that's hitting quite yet, but it's going to come soon. As you can see, it evolves. It's got quite a bit of stuff in it. Okay, this is a dense structure. So this is why NOAA has given the G2 warning. Okay. Now you can also see over here, if you were paying attention, you can see something lifting off this way. I'm not sure, that might actually be the filament, that other filament I showed you on the Earth-facing disk. I forget, it's awfully early. I don't know if it is. It might be a little early for that. Then, of course, 2887 just can't get enough of itself. It fires yet something more. This one I don't think is got any type of Earth direction to it. Sorry, no, that's not aliens. This is not aliens, guys. This is just an anomaly. Okay, this is stray light in the detector. For whatever reason, a filter wheel or something did not do what it was supposed to. Oh, it can't be a filter wheel, but something just did not do what it was supposed to do. Okay, trust me, nobody's blinding the instrument. Big Brother is not hiding anything. Stuff in space doesn't always work well. Am I going backwards or forwards? Okay, forwards. And see, then the algorithm can't figure out what it's supposed to do with itself either. So we got more junk coming out of 2887. Okay, and then, oh yeah, and then we have, okay, then we start over. And then this is stuff coming from a region on the sun's far side that has yet to rotate into view, but it's busy in stereo. Okay, and I'll talk about that in a little bit. So we have yet more stuff, and this is once again, this might be again from region 2887. Looks a little too far north, but region 2887 is very busy, and it is continuing to be busy. It'll be very interesting to see in 2 weeks when it rotates back into Earth view, if it's still going to be around and still a player, because it's not quieting down anytime soon. So I lost count. Did anybody happen to capture how many CMEs we actually saw in this set of Coronagraph images in 2 days, 48 hours? Okay, this is a nightmare for Space Weather Prediction Center people. And in this case, here is the, I'll play this model for you. The the American Center, NOAA, only shows for NLO, only shows essentially maybe 3 CMEs. Okay, if I make it big. Hopefully it'll play again. So this is NOAA's version of NLO. The top panel's density, the bottom panel's velocity. And when it resets, you can see, we're looking down at the North Pole of the sun, you can watch these solar storms comes out. They've got 3 of them, okay? And they have, if anybody watched the model last night, saw that they actually had the one that comes out that's direct toward Earth, that's that full halo. Last night they had a model run where this thing was coming out and hitting Earth before the at like the latter half of the third. Do I think that's this solar storm? I don't think so. I think what this solar storm is that's hitting now might actually be the one, and I'll wait for it to reset, and then I'll pause it. Can I pause it this way? Hold on. Hopefully I can. Oh, no. Of course not. It's not going to let me do it that way. I was hoping the space bar might let me do it. You can, there you go. So zoom in. If you can see these little guys, look at these little teeny tiny guys. Okay, so early, close to the sun, you can see 3 distinct structures that NOAA is modeling here. 1, 2, and 3 over here. Okay. This guy here, this is the one that region 2887 blew off at the same time it blew off the, well, no, a little bit earlier than it blew off the filament. Okay. This was a very fast structure. This is the structure I think that might be hitting now. Okay. This structure here, it's a little bit further inside, is got to wait behind that first structure. But I think it's going to be really close together. Okay. The reason why I say that I believe it's this first structure is hitting now. It's because it was an extremely fast eruption, and the speeds that we're seeing right now in the solar wind are like 700 kilometers a second. And it went from something really slow to something really fast in a very short period. And I'll show you what that does to Earth. Earth does not like that, but it's very interesting. But before I do that, if I guess I'll be honest here. I'll let this play to where we actually get this thing, sweeping it up and almost passing. So you can just at least see when NOAA thinks this thing is going to, the bulk of the stuff is going to hit Earth. It's looking early on the 4th, okay? And I think that's a pretty good prediction for at least the bulk of the stuff. We are already seeing something hit now, okay? But the biggest part of the storm has yet to hit, and I do believe it'll happen early on the 4th. Now, let me show you something fun, because the Mosswalk, I think, has done the most. Oh, wait, I think I have it. Yes, I have it up. The Mosswalk, I think, has done the most honest modeling job, if not the cleanest. So let me play this for you. So this is the Mosswalk. This is the Met Office's version of the NLO model. And of course, these guys talk. So this time series is showing that the bulk of the storms are going to arrive at the same time. So they honestly believe, or they have come to a consensus with the Space Weather Prediction Center, that the bulk of the storms are going to arrive just before 4 a.m. on the 4th. But if you notice, look at these structures. Look, there's like 5 of them. You see them all out here? It's like the sun is going and just machine gunning. We've got 2 regions plus 2 sets of filaments that are all firing off. So, you know, when you have 4 source regions on the disk, and one of them in particular is extremely angry, you're going to get a lot of solar storms being fired all at once. So that's what you're seeing here. And I'll try to pause this at a convenient spot. Yeah. So I don't know if you guys can see this, but again, top panel's density, bottom panel's velocity. You're looking down at the sun's north pole, and in this case, onto the ecliptic plane. So here's where stereo A is. I should go check to see if stereo A has data showing it's been hit yet by this solar storm. It kind of gives us a little bit better feel for how well these models are doing. And then we've got the direct hit. In this case, they've got the direct hit kind of merging with the hit in front of it. Okay, which really in real life doesn't happen. These models don't take into account the magnetic field as an active player. In these models, in order to run them faster than real time, the magnetic field has got to be a passive player. So in other words, there is magnetic field in these models, but they're just along for the ride. They don't exert any forces. And that causes violations of certain laws, Maxwell's laws, for those of you who know. And so that's why you're able to see, in this case, the storm, the direct hit storm, actually being able to not just overtake the earlier storm, but pass it and mingle. They don't really mingle. They slam into each other, but they stay distinct. And the one behind can push the one in front, but they have to stay discrete, because magnetic fields actually do exert forces and require that. You know, they're like bumper cars, right? So basically the storm behind has to push the storm in front. But I think honestly the storm in front is probably a little bit more energetic than the storm behind it. It's just that honestly, when this mess hits Earth, I think it's the bulk of the storm, the stuff that's going to really slam Earth, because it's dense and big, and we're hitting it right in the face of it, right in the apex of it, the center of it, as opposed to the flank. I think that's really the one that matters in terms of strong and potentially sustained storming. What we're seeing right now from this earlier one, it's a nice hit and it's pretty fast, but I'm not sure how long it's going to last before things maybe quiet down just a minute. We'll see. So the nice thing again is that these space weather centers are talking to one another. And here we have a hit that is, oh, well, no, they're showing it just early. I thought they were having it right about early, right on the 4th, but they're having it late on the 3rd, which is, I think, pretty much now. So, you know, maybe not such a bad model after all. I think maybe the Mosswalk wins the gold star this time, because that's what we're beginning to see. Speaking of seeing it, let me now switch to the real-time solar wind, just so you can see what it is, and then I'll show you what it's doing to Earth. So this is what we've got right now, guys. This is, for those of you who are familiar, this is solar wind data. And I will see if I can stand. No, I can't. All right. I'll stand here where the quiet solar wind is. So the top panel here is magnetic field strength. Don't worry about the second panel. It's just an angle that lets us know, again, the orientation of the magnetic field. Third panel, orange, is density. Fourth panel is speed. Fifth panel is temperature. Anybody who knows how to read data knows that we're having some issues with, I think this is Discover. I don't think this is ACE. ACE plus Discover, I don't know which one's active. But these are likely, if this is Discover, these are likely issues not real. When you see these these drops and then back up and then drops and back up, that's not real data. This is a Faraday cup issue, likely, and we're getting software mode changes trying to deal with it, and it's not dealing with it very well. Likely because when we get really intense hits like this, it messes with the instruments. Not so much that we can't read it, but we don't necessarily go in the right gain, the right mode change right away. And so what ends up happening is that you have very smart people like Ruth Skog, if she's still out there doing this, going back through real-time data and turning it into level 2 data. She backs this stuff out. She finds out what the real count rates are, and then manually has to go back and retabulate what they are and then recreate the moments so that they don't look ratty like this. But this is what we suffer with real-time data, okay? Instruments glitch all the time. It's not catastrophic. It just means that they're trying to keep up with big changes really fast, and it's hard, okay? So, because the solar wind has a lot of dynamic range, and it's really hard to kind of encapsulate that in one, especially with particles, in one instrument. So we have ways of doing that, but it doesn't always work perfectly. So we always have to go back and do. That's why there's a difference between level 1 data, which is this real-time stuff, and level 2 data, which has been vetted. Okay, that's what scientists use to do work. All right. Anyway, enough of that. So as you can see, we were very, very quiet. Okay, all prior to this. And now we got hit with a decent sized solar storm. Okay. This thing has jumped up to about 20 nanotesla. That's the white line up here. And early part of the storm was southward, a good 10 plus nanotesla south. Okay. And oh, by the way, magnetometers don't have nearly the problem that plasma instruments have. So while you'll see dips and stuff in the plasma instrument, you won't really see it in the magnetometers. Magnetometers can handle it. It's very rare that a magnetometer has a glitch. So when I look at this dip here, that's probably real. Okay. Maybe not, but probably. Anyway, getting back to it, you're seeing a decent sized jump in density. Look at the higher levels. Not too bad. You know, what's like 20, maybe 25, 30. Yeah, okay, that's probably the compression region. Where you get excited is the solar wind was about 500 kilometers a second, and it jumped up in a matter of like an hour. It jumped up to almost 700 kilometers, past 700 kilometers. And you can see it's actually looking like it might be climbing. Now, I need to vet that with maybe ACE data or some other instrument out here. Whoops, put my hand in the right place. To make sure that that's not an instrument issue, right? It's always better to vet it with multiple instruments so you can tell. But nonetheless, this is fast, you know, even if the numbers aren't completely accurate. Earth doesn't like to be hit like this. Where everything's just stumbling and bumbling along and it's real fine, and then suddenly you get hit with 20 nanotesla field at 700 kilometers a second. No. So Earth is responding right now. And even if notice that the field has gone north up here. For all of you Aurora photographers, take note. You may not see Aurora right now, even though the magnetometers are likely going nuts. Okay? Nothing's wrong. It's just that the field is northward, and unless you're really far north, you're probably not going to see any aurora. Okay, but the Earth's magnetic field is wiggling like crazy because it just got rung like a bell, right? Bong, and it's just going to reverberate for a while. Okay, but that doesn't necessarily mean you're going to see aurora. As a matter of fact, if I go to, and I'll show you what I mean. Let me do the AE index. For those of you who are familiar with AE index, it's finally settling down. That's good to see. For those of you who are familiar with the AE index, I can stand in the right place. I'll stand over here. AE index is a measure of the aurora electrojet. And we can look down here at the bottom numbers. The bottom numbers are essentially kind of a combination of the top, the AU and the AL index. But we'll just look at AE, which is basically the top number here. So the upper envelope here. Notice everything was nice and quiet, and suddenly it went up past 2,000 nanotesla. Get my hand in the right place over here. See that? Off scale. This is Earth being rung like a bell, okay? And notice it's finite. It's taken a little time for it to settle down. It's still sitting at, like 700 or 750. If I move my hand out of the way, you can see where the data is right now. It's still sitting about 750. Where Aurora is typically visible is when you see this thing around 500 or above, okay? Except the fact that this is still just reverberation to a great degree from the big hit it got slammed with. So unless you're at high latitudes, you're likely not going to see Aurora right now. Doesn't matter that the AE index is talking like this. Okay, just understand that this can happen, and we have to wait for the field to go southward again. But if we continue to have sustained fields strength of 20 nanotesla or nearly 20 nanotesla, and the speed stays at 700 kilometers a second, wahoo! That's a big deal, and that will probably put us at a G3. So just be aware of that. Now, do I think that's going to be sustained? No, I don't, because I think this is a glancing blow. Let me go back to the real-time solar wind here for a sec. Now we're still staying high. Pretty impressive. So maybe not as glancing as we thought. It's staying high. Yeah, it's almost 800. Geez, yeah, this is an eruption. This is not fast wind. For anybody who thinks this might be fast wind, no way. We haven't seen fast wind streams that high for a while. And this just came so fast. So I wonder why we didn't see a shock. It's interesting to think of. But we had some fast solar wind just the other day. I thought it was actually a solar storm hitting, a CME hitting, but it wasn't. But this, when you see speeds this fast, we've just bumped up here. This line, if you can see it, this line now is 800 kilometers a second. And we've just bumped above that. So again, maybe I should switch to see if we have ACE data available. I almost don't want to get rid of this bookmark. If you guys can bear with me, I will check ACE. Come on. Let me duplicate this, and let's just look, because although ACE isn't, ACE has its issues too. Let's see what we got. Here's 6 hours of ACE. It's saying, yeah, its magnetometer is saying 20 nanotesla. Almost easily, maybe over, or right above my head. It's like about 25 nanotesla. Speed, yeah. If I get put myself out of the way, we're jumping above 800 kilometers a second. They may actually be using ACE data at the moment. So you see that? And if you trace your eye all the way over to the other side, that's 800 kilometers a second. It's the highest tick here. That's 800 kilometers a second. So yeah, we're seeing something big. Okay. So if that field stays northward, you're not going to get huge Aurora, and you're not going to get huge KP. Okay. We might end up seeing a G1 even with the field northward, but if that field goes southward with this high of speed, yeah, it can get to a G2, even a G3 really fast. Even with only about 5, if the magnetometers go down, if this goes down and goes to a negative even 5 nanotesla, at 800 kilometers a second, you could see a G2. Okay, easily G1, definitely, but possibly G2. Depends upon how long it lasts. Obviously, the longer it lasts at these high speeds, the bigger chance you have. Okay, so let's just be paying attention to this. And again, I don't think this is just the first of several. So in this case, everything that we thought the Halloween storms were going to be, this is more like what we had been expecting. In the end, I think what we figured with the Halloween storm, what happened was that that coronal hole, that polar coronal hole, if I go back to it real fast for you, just for those of you who want a little forensics analysis, we were talking about this stuff offline. This coronal hole that I'm standing in front of, Surprisingly, despite the fact that it really didn't have that much of a southward extension, this coronal hole up here was very robust, and it actually had wind that was dipping down into the equatorial plane, because we actually got some fast wind from that coronal hole. And so what we think is that maybe that really pushed that event, that Halloween storm that we already knew was going to go south, kind of south of us, at least the densest part of it was going to go south of us, pushed it almost completely south of us. We did graze the northern edge of it, but the magnetic field strength was really weak. So it did proceed, and it did hit us around the same time that the models predicted, but it was so far south by the time it hit Earth, it didn't really do much. The magnetic field was really, really weak. But that's part of the thing, is that when we have these polar coronal holes, you think that they're too far north to actually give Earth some fast solar wind clear down here. But these things, the way that sun's magnetic field works, is that the polar field actually comes down and then goes this way, and that has to guide the solar wind, right? So you get these, you can actually get fast wind streams that dip down. It's just we didn't expect it nearly as much from this region as we expected, or as we ended up getting. And that's our best consensus right now, between the ones those of us online who are talking, and then even a couple who are not online but are talking via email and other things. So get mad at me, get mad at Erica, get mad at Chris, get mad at Ian, Nariaki, and myself, because we were the ones who were discussing this. And no, I'm not giving last names. If you don't know them, then good. That means you can't yell at them on my behalf. Because then, I'd rather you just yell at me. Just yell at me. Pelt me with olives. Okay, so let me show you now, since we were going back and talking about the ACE data and the Discover data and how hard this is hitting Earth, let me show you. Because I guarantee you, we're going to have conspiracy theories and all sorts of crazy things talking about these magnetospheric models, because they're just really cool looking. Now, first thing, to debunk anybody who's going to, whoops, don't do that, who's going to talk about this, if you see this on other people's channels, okay, first of all, this is not data. This is a model, okay? Anybody who says this is data doesn't know what they're talking about. This is a model, okay? This isn't real. We haven't had spacecraft making all these observations. Okay. Secondly, this model, in this case, the panels that I'm looking at are talking only about the velocity, the speed of the solar wind coming in, and then the speed of anything that's going on in the Earth's magnetic shield. Okay. And I'll tell you why that's important in just a second. But what I want to show you, this, for example, is looking down at the North Pole of the Earth. I almost said the sun. Okay, this is the North Pole of Earth. Okay, dawn is this way, dusk is this way, meaning the Earth rotates. Okay, the Earth is rotating this way. Okay, the night side of Earth is here. This is the comet tail that is the Earth's magnetic shield being pulled out. Okay, this is the solar wind slamming into the Earth here. Okay, you can see this is velocity again. So this is the speed. So when this thing starts, you can see, don't look at that stuff yet. When it starts over, here we go. You can see it's kind of a bright red, and then it gets darker red and darker red. The darkers mean faster solar wind. Okay, solar wind's blowing this direction, which in this coordinate system is negative. This is the negative direction. That's why you see this dark red being a negative number. Okay, and notice this says 800, meaning 800 kilometers or so. Remember, we were looking at that ACE solar wind. It was over 800 kilometers. That's why we're seeing this. Okay, this is 800 kilometer a second solar wind slamming into the front of the Earth's magnetic shield. So if I now, let me stop. So this is prior to that happening. Okay, see how nice and jellyfish looking? It's very nice and pristine. Okay, this little finger right here is actually showing, yes, you guessed it, blue. This is not solar wind. Okay, this is velocity, this is speed, and yes, it is going toward the far side, going toward the night side of Earth. This is the slingshot, folks, that I've been talking about for ages, right? I always talk about you draw back the Earth's magnetic shield and then you cut and bling, and it slings stuff back at Earth. Ding dong, that's what this is. I can't tell you how many times I've been slammed with people saying, oh, this is solar wind going backwards. No, it's the Earth's magnetic system doing its job. Okay. But why this is important in this case is because when you get hit with that 800 kilometers a second speed, right, suddenly all this energy gets pumped into the Earth's magnetic system. That slingshot's going to get pulled way back and it's going to slam forward real hard, right? And then when that solar wind relents, right, that slams super hard and then relents, the Earth's magnetic field goes from being really compressed to, I get to breathe. And then it gets slammed again, it compresses down, and then it relents, and it goes, I get to breathe. And you remember how we were talking about the dance, right? Here's the dance in, those of you who know what that is, from my mini courses, right? You get to see it in real time. So here's some slamming, right? And you can see it crushing that magnetic shield, okay? And then, whoa, it breathes. Oh, goodness. Thank goodness. Oh, and then, slams again, right? And it's still getting slammed, on and off, but you can see, and I get to breathe for a second. Oh God, I'm getting slammed again. So you can see the magnetic shield is really kind of like a balloon. I mean, it really does respond to how much pressure is being slammed at it at any one time. Now, let me, and I should have stood on, I think I stood on this side, didn't I? Yeah, I did. Okay. So what I want to show you here on this side, north, south, Z. Okay, good. Sorry, it's mirrored, so I just want to make sure I'm standing over the right panel. So what you can see here far better is that dark blue. See the dark blue? Here's the slingshot in action from the right angle, because now we're looking at the meridional cut. We're cutting north is this way. Okay, this is the North Pole now. Instead of looking down on it from the North Pole, we're looking from a side view. In this case, we're looking at it from the dusk view. Okay, here's the North Pole. Here's the South Pole. Okay, sun is this way, right? Tail is this way. Okay, so I'm pulling this slingshot. If I get my hand in the right place, I'm pulling it back. And then whoosh, see the blue? See how the blue shoots it forward? Okay, you'll see that in action. You can actually see the slingshot because you can see it coming like a Y, almost like a wishbone. That is the slingshot, guys. It's being pulled back. When you see it going all red, that's stuff being pulled back. That slingshot is being armed. When you watch that red stuff come out, see, look at the red. You're arming the slingshot, and then whoosh, it goes blue because it's shooting all back this way. Okay, then you get Aurora. Well, I should put my hands in the right place. You get Aurora shooting up, going zip, and then into the poles here, north and south. Right? So anytime you see that blue, like you see it right there, right, that's when you get Aurora. So if I can get my hands out of the way to some degree, you can watch it there. It's getting loaded, armed and armed, and then ready, zhoosh, there it's shooting back, and you're getting Aurora. Okay, that's what's going on in this model. So any of you should, if you've watched this stream now and you see anybody else talking about this stuff, A, it's not data, B, it's not solar wind stuff. This is the dynamics of our Earth's magnetic system, okay? And it's showing you in real time how dynamic this system can be. And hopefully this gives you an impression and gives you an understanding that yes, you can have the Earth's magnetic shield ringing like a bell and not have Aurora, especially if the field's northward, because you can be loading stuff or you can be changing stuff, right? The magnetic field can be reconfiguring, and it doesn't necessarily have to be shooting particles into the upper atmosphere to make Aurora. It could just simply be ringing like a bell and reconfiguring internally, which is what it does a lot. So for those conspiracy theorists that you see doing that kind of stuff, just laugh because they're not credible. All right, so one of the things I wanted to show you really fast, I guess since we're on Aurora, we'll do Aurora. Let's do Aurora. Yeah. This is what Aurora was doing just a few minutes ago. Not too bad. I remember James Rowley Hill on Twitter saying, oh, Scotland's not going to get anything. The UK is not going to get anything. Yeah, right, guys. You're actually getting hit, so hopefully they're paying attention because they could conceivably get stuff right now. Let's see if I can almost start this at the right, so that they both go at the same time. Oh, maybe a little behind. Sorry about that. So north and south, I wish these things were coupled so you could watch them turn and spin at the same time. Here's where we were. I believe that was last night. Gosh, I don't know. They say a 30-minute forecast. So here's, you'll see it. Watch how quickly this thing turns on. So you'll see the aurora kick in real fast. Ready? Which is getting close to the real time right now. Super quiet. And then look at it turn on like that. Okay. So they're both in the north and in the south. We're getting aurora, or at least we have been right prior to the field turning northward, because you can see it actually died down. Here's a perfect example of the southward component dying down. But right prior to that, we were getting some decent aurora. Yes, we have hit over, for those of you who know and pay attention, over 107 gigawatts by standing in the wrong place. Okay, so can we get a G2 out of this? Yes, we could if that field goes back southward. And you will see it come on fast, and it will go down to mid-latitudes, because that auroral oval will open up really quickly. When you have 800 kilometers a second solar wind slamming into Earth, you energy load real quickly, okay? So just be aware of that. The speed will be key in this one. Let's see. Let's just take another quick check. Yeah, I think the field is still northward, because as you can see with the AE index, we've really come back down. Okay, so we'll have to wait for that field to go northward or go southward again. Now let's see, was there anything else I wanted to show you? Oh yeah, my 5 days. Oh, do you guys want me to do stereo? Because I have not looked at stereo. Give me a thumbs up if you want me to do stereo real fast. And I am sorry I have not looked at anything in the chat yet, because I wanted to get through this, and it's already almost an hour. Talk about, yeah, briefing. This is a long briefing. Yes, stereo. Okay. So we've got some people saying stereo. Yes, stereo. Okay, good. And thanks for staying on with me, guys. Oh my goodness, there's almost 1,000 people on. That's fantastic. Thank you. Thank you so much. Whoops, don't go to 5 days. I'll go to 5 days in a minute. Let me go to stereo first. I believe it's stereo, yes. So we will both be looking at this together. I looked at it a short while ago, but not over the, let me slow this down. This is just from November 1st. This is just for November 1st, so I haven't looked at it in the last hour or so. So we'll see what this shows. Okay, so we're back on November 1st. Good. Okay, did it already launch the big one? That right there, that was region 2891 that launched that monster. So I'll wait for it to reset here in a sec, and we'll start again. I think it shows, so when it resets, you'll see that's region 2887. It's already out of field of view. There we go, in stereo's view. But it launches a couple. Then you see region 2891 launch right there. And then shortly thereafter, or was it before? I think it was right before. Yeah, that was where that filament eruption launched. And then you get this long filament burning right, if I can get my hand in the right place, above my hand here. So we'll let it reset again so you can get oriented. Here's this region launching stuff. The filament launches over here. You probably can't see it. Didn't region 91 goes off, and then you get this burning over here. Watch this region in this area. You can see it. If I move my hand, you can see it, the dimming region kind of change. So that was actually a pretty big filament, to be honest. But I think that's one's going to go toward stereo. I don't think that's going to go toward us. Where I want you to keep your eyes, since we've already seen all these eruptions from the front side, I want you to keep your eyes on this region here, especially, okay? This region's a solar storm producer. So this is where I think some of those, remember I talked in the coronagraphs, we actually saw some stuff that was going south of Earth? Right. This, and I said that they might be backsided or farsighted. Sorry for those of you in the UK, don't like the word backside. Oh, I said it again, didn't I? Oops, sorry. Anyway, it's humor. You have to get used to my sense of humor. This region here is actually one of the culprits of firing off the far-sighted CME or solar storms that are making it a little bit tough for space weather forecasters to look at all this stuff and see through it. But what that does mean, I mean, that's good and bad, right? Because the good thing is that by it being so active and being a storm producer, possibly an M flare player, we'll see, But being large like this means that this region will be a good source of solar flux. So if you're looking at the Space Weather Prediction Center page and you're seeing the forecasts for solar flux to dip back down into the 80s, I don't think so. Okay, I think it may stay low 90s. They're basically banking that region 2887 is the only thing that's giving us any solar flux, and as it rotates off of the sun's west limb, that it's going to, that's going to be the end of all. No, I don't think so, because this region will be rotating into Earth view here probably in the next 3 days. We're already beginning to see a little bit of its wispiness in SDO already. So we have that region that's going to be a big solar flux player, and then we've got a little bit of flux from these wispy regions up back in here too. Don't know how these are going to play. These look pretty quiescent, the ones that show and rotate here. Oftentimes you get what's called the limb brightening, which means the regions look much brighter on the limb than when they rotate into view. You go, oh, this is nothing. So don't be fooled. These may not be that bright as they actually rotate into stereo's view. But this one is a player. So that's good news. So outside of that, I'm not seeing any other big players. Region 2891, which is this guy here, could it launch another solar storm? Possibly. It's going to reset. Possibly. I think we got the best of it though, because it really launched a classic one. This eruption, which was center disk in Earth view, boom, right there. That one is. If we see something more from that, I don't think we're going to see anything nearly as a massive or as enticing as what we saw from region 2887, which kept on firing and firing and firing. We'll be watching that one fire stuff from the far side. So just be aware, if you watch Coronagraph images and you keep seeing stuff firing off in the south, they may not be Earth directed. That may be region 2887 firing stuff while it's on the far side of Earth. Okay, or far side of the sun, far side of Earth. I'm silly. Okay, so there's stereo. And so this will give you a little backstory for my 5 days. Excuse me. Yeah, I've been doing a lot of live shows recently. My voice is gone. So as far as solar storm conditions and aurora possibilities go, yes, major storm is quite the possibility at high latitudes. Okay, as a matter of fact, NOAA's giving us about a 75% chance of a major storm on the 4th, and even into the 5th and the 6th, still quite a bit of chance. I think it said 55% by the 6th. But definitely major storms into minor storms, and then possibly by the end of the weekend we'll be settling down. It's hard to say. I mean, we've been getting a decent storming, and it's been kind of on and off. And remember how I've always said that when the Earth's magnetic shield gets rattled, that kind of preconditions it to be rattled, right? It's like having multiple headaches. After a week of headaches, it doesn't take much to really set you off. Earth by this time it's frustrated. It's like, just leave me alone, okay? I'm grumpy. And so we may, especially at high latitudes, could easily be storming in through the weekend and possibly a little bit past it before we finally calm down. Mid latitudes, I'm departing with NOAA's forecast just a smidge because, yeah, we've just got hit by something faster than we thought. And at 800 kilometers a second, if anything like this sustains, holy poop, we could easily see. Is holy poop a technical phrase? We could easily see major storming even down at mid latitudes. And yes, G2 definitely possible, G3 even possible if we sustain at 800 kilometers a second, absolutely. And then hopefully by the 5th, things will calm down. Still a smidgen of a chance of a major storm, but probably not, down to active conditions reasonably quickly, and then quieting down from there. Okay, so aurora photographers, keep your eyes on the AE index, keep your eyes on southward magnetic field, because if we see that, yeah, you could get beautiful storm time aurora clear down deep into mid latitudes. Okay, but it's going to have to be sustained, right? That can't just come and then go, because that's not long enough. Aurora oval takes a while to get down, but it will open up quite quickly. So those of you who are on the Great Lakes regions, yeah, you guys could be watching all night. Those of you who are down in lower latitudes, like Colorado, Iowa, South Dakota, stuff like that, you know, just keep your eyes on it. You may not get Aurora shows other than sporadic, but we'll just have to see. And then obviously follow us on our community on Twitter, because that's the fastest way to get info if you can. And there's just so many field reporters out there that you'll probably find one in your vicinity. So they'll keep you apprised as to whether or not Aurora is happening in real time. Okay. And now, as far as solar flare and particle radiation storm outlook goes, ooh, I apologize. It shouldn't be, or it shouldn't be. I forgot to change the colors here. This should be all yellow. And oh man, I really messed up on this one. Look at this. What did I do? Let me fix this. This should not be. I'm gonna be sitting at like 5%. Probably now down to 1% is what I'm gonna say. Sorry about the colors. I'm gonna leave the colors not looking so great. I'll just put them all as yellow. But they really need to go down to green. I guess I can go down to green here, just so you can see. I'll just make it light green because it takes too much time to change it. But I just really don't want you to think that things are really too intense, because they're not. This is what happens when you do things quickly, right? So when we switch to our solar flare and particle radiation storm outlook, yeah, we do have chances for an M-class flare at about 10% right now, which will wane very quickly because region 2887 is rotating off of the disk, and region 2891 looks like it's kind of calming down. And we don't have any other regions on the Earth-facing disk that look like they could be M-flare players right now. But we do have that one that's going to be rotating into stereo's view, that you're kind of seeing it rotate into stereo's view. So this may go down to green and then go back up to yellow. We'll just have to see. Don't think anything as an X-flare player, though. So don't worry about that. That risk is gone. Obviously, these regions are going to be changing. As soon as region 2887 rotates completely off the disk, the solar flux is going to drop. Again, I think I have these numbers not quite right. Oh, and I did depart with SWIPSy, because I think in the 90, I think this third day they have it is like 85 or something. Ugh, no, I don't think so. I think we're going to start going back up into maybe the mid 90s by the 3 or 4, about 4 days, 4 or 5 days, mainly because of that other region that is on stereo's far side. And then just know, I didn't show that radiation storm level. I'll go back and show that. We're now at elevated levels, but we are just below the S1 radiation storm. We were actually there just a few moments ago because that shock wave from that solar storm was so strong, it popped us back up to S1 radiation storm levels. We're just now below that, and that's going to continue to wane as we get through the weekend. It will be back to normal conditions, I believe, because I don't think there's any other shock waves out there that could cause issues. The nice thing is that this isn't high energy stuff, and I will go back to it to show you. I think I just have a homepage up, yeah. So I'll show you this. So here's the radiation storm levels. I'll just stand it. Well, I won't stand in the middle. You can see here's this dashed line is the low energy. There is such a thing. These are energetic particles. So relative low energy stuff. This is the 10 MeV particle stuff. And as you can see, we were kind of beginning to wane a little bit from the storm, the radiation storm that we had already, right? We had it back from the Halloween storms. Well, it never totally went down. The high energy stuff went down to baseline, which is these flat lines here. But the low energy particles, again, relatively low, these are still high, energetic particles, and still can penetrate spacecraft and aviation and avionics and stuff like that, and passengers. But it's the lower energy of the side of things. But we did peak at the S1 level. So those of you who go to the Space Weather Prediction Center and you see that S1, within 24 hours light up, it was because of this. But for those of you who know what this is, every time a shock passes Earth and there happens to be radiation storm going on, it will peak and then go back down. So that's what we're seeing. And it looks like we will now recover easily within the next few days. We'll end up recovering as the rest of these storms pass through. I feel like I'm a cold front passing through. The radiation storm will die down back to normal levels. And nothing more to worry about. So I wouldn't worry if you're a frequent flyer. I wouldn't worry too much about taking a flight right now. Obviously, if you're a high risk passenger, you have to deal with it a little bit, but it's not too bad. and it will continue to wane. So I only have it until about the 5th. That may even be a little bit. I just say I wanted to put an S1 risk on here, saying we have about a 5% of a risk, just because of region 2887. It is still very active, and right now it's in a place that it could fire when it launches big flares and big storms. It could easily send us a radiation storm, and that's actually where it's located on the west limb is actually a very well connected. Let's just put it that way. Well connected place to Earth. Believe it or not, it seems weird, but it has to do with those pinwheels that we talk about when we talk about NLOP and the way the solar wind works. So we're probably still going to have a risk over the 5th, but by the 6th, I almost can call it normal at this point. So so don't worry about flights. You should be fine. And you know, at past the weekend, everything will be nice and calm, and then we'll finally maybe get a calm stretch. But radio propagation still should be pretty good on Earth's day side, except, you know, with a solar storm, it could be a problem. On Earth's night side, it's going to be very unpredictable and sporadic. GPS users, you need to be extremely cautious, not just on the dawn and in dusk, but on Earth's night side completely, especially if this auroral oval comes way down. If it does, you're going to be dealing with scintillation, you know, reception issues for GPS, and you may get your GPS receiver may go, oh, I'm there, I'm there, I'm there, I'm there, I'm there, and it may just like do all sorts of weird things, or it may just not lock at all. You just sit there for 20 minutes trying to get a signal lock, and you can't. These are the types of things that happen when you have big solar storms like this, and Aurora is nearby. So just fly safely, fly carefully, okay? And I think that's about all I have for you guys. So I will take questions for a little bit if you guys are still with me. I appreciate it. It's been a long briefing, but hopefully this gets you up to speed. Okay. Whew. That was a lot of information. And yes, for those of you who are, you know, who wonder, I do read all of the chats over time. And I will look back and catch everything you say. By the way, radiation does not make it to the ground, so don't worry about it. It's at high altitudes, but doesn't make it all the way to the ground. Yeah, thanks, Mike. I appreciate you putting the links in the chat. Very much appreciated. It's a new maximum. Yeah, we're not there yet. Things, believe it or not, this is just the beginning. So it's going to get more and more interesting as time goes on. A big one these days could disrupt our society. Yes and no, not as much as you think. Because we've got, you know, again, these storms are common, believe it or not. During active times, G2, G3 level storms happen a lot. And the reason why they haven't been reported as much is because social media didn't really exist, you know, until recently, till moderately recently. We've been sitting at a solar minimum for about 3 or plus years. So the sun really hasn't been doing all that much. But you know, this community has grown dramatically over the last 3 years. So we're getting a lot more information out there. But space weather is not something to be frightened of. It's something to embrace as part of your normal weather. Especially as we become more spacefaring. So don't stress about it, guys. It's okay. Good. I'm so glad I'm seeing lots of thank yous and good information. You're very welcome, guys. And I'm sorry I'm not mentioning your names. It's just the chat is moving by so quickly that I'm having a hard time seeing it. Thank you. That's so kind. I see hearts and claps and hearts and yeah. Intermittent problems all day long. I don't know if your cell phones, if that is related to this. Again, this has only been hitting the solar storm. The first set has only been hitting over the last couple hours. So I don't think that's space weather related. And typically cell phones aren't a problem. It's more your space-based assets, things like GPS reception, those types of things. Or if you deal with, you know, radio communications in certain frequencies, that can be a problem. Satellite phones can have issues too. Although we're not having a lot of radio bursts right now, from big radio bursts from these solar flares Right now, it's more going to be for the average person, it's going to be more about your GPS, your Waze, your Uber, your Lyft, that type of thing at high latitudes. If you're an amateur radio operator, it's going to be issues with that. If you're an emergency responder and shortwave should be fine, direct line of sight communication will be fine. But of course, you guys work with amateur radio operators, and a lot of you do search and rescue with GPS. So that's why I always include emergency responders when I talk about this stuff. But skywave propagation is the big issue here. Oh, thanks, Chris. I see you there. You said great brief. You're right. It wasn't very brief. This is a briefless brief. I tried, guys, but I'm terrible at it. I am. I'm still trying to get better. My Patreon helpers or supporters are helping me get briefer, more brief in my briefs. They're actually training me how to do this properly. Otherwise, I talk forever. You guys know this. I'm awful. Now for the other hand clapping. Cute. Wonderful update. Oh, thank you. You're so Space Wonder Woman. Yeah. Thank you for that. I appreciate that very much. Someday I'll wear a costume. Dun dun dun. Right? No. No. I will not wear a Wonder Woman costume. I promise. People will be like, "Oh, my eyes, my eyes." Okay. Any other questions, guys? I see lots of good stuff. Yeah, 67 minutes. Big day though. Was a big day and very long brief. And I apologize for those who wanted just the facts, ma'am, and then get out. It didn't quite work that way today, did it? Still waiting for the Aurora to drop to mid. Yeah, I know. Let's hope. It'll come soon. We just got to pay attention to the real time stuff. So again, those of you need to get on Twitter so you can monitor the conversation in real time. Definitely, that's the best way to get real information as to whether or not you should go hunting for Aurora. Get on Twitter if you can, because that's where all the real time reporting is occurring. And yeah, any fool can know. The point is to understand. Nice. I appreciate that. Great, guys. Good. I must have answered lots of things because I'm not seeing. Oh, I see one question. What was the rating of the most recent solar flare? It was a C7 or something. If I go back to that homepage. Yeah, we were watching. I was watching it unfold. Actually, I was talking to Matthew Shipley, who has his own really space weather channel, and I'm trying to work with him on some stuff. And let's see if I can get out of this. Escape. Get out. Oh, come on. No, I don't want to download. I want to get out. How do I get out of this? Thank you, Swipsy. Okay. I'll do a 3-day and just make it big. So this is the X-ray flux for those of you who know. And whoops, am I standing in the right? Yeah, I'm standing in the right place. So you can see a couple of the big M-class flares. This is the M-class line, the big threat level. Okay, so you can see a couple of the M-class flares recently. This is the big halo eruption, if I recall, on the 2nd, right? You can see how it's a gradual flare. It really lasted a long time. A lot of energy there. And we really haven't seen a lot of really big flares since then. This was, I believe this was region 2887 yet again. And it only is a C-class flare. And I will look and see what it was. The reason why is not because this is a C5. Not because this really was a C-class flare, but rather because that region is occulted now, meaning it's being blocked partially behind the limb. So this could easily have been an M-class flare. That region is still mad. It's a bad actor. I mean, this is what I'm talking about when I talk about machine gunning. You've got a bad actor that rotates into view, and it just fires off storm after storm, radiation storm after solar flare after solar storm, boom, 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 and it just keeps doing it all the way across the Earth-facing disk until it disappears on the sun's far side. And then it probably fires and machine guns back there. So that's the thing with space weather, is that you oftentimes will have these quiet periods where nothing's going on, and then you get a bad actor or several bad actors on the sun, and man, things go to heck in a handbasket real fast, because these regions just nonstop pummeled you with space weather events. And that's really where the issue comes when you talk about extreme events. It's not always just one event. Everybody says when a big event hits Earth, they're so busy focused on Earth, they forget to look back at the sun, because the sun's not done. So every time these events happen, I have one eye on the Earth and I have one eye on the sun, because I know not to turn my back on that thing. The sun is not something you turn your back on, especially when it's got angry, angry beasts on it. causing trouble. And so, yeah, when we look at I turn the right way, you can see region, that was that flare right there. That was the C-class flare. You can tell when you see that region rotating off the limb, you can tell that was not a C-class event. Okay, there's an M-class, or there's one smaller event right there, but watch this thing when it rotates all the way off. You see a lot of field opening up, a lot of changes right there, right? Ready? Come on. Boom. So I think that was probably an M-class flare. We just couldn't see the whole thing. So hopefully that answers that question. But that one did not launch a radiation storm because I've been watching, and we would have started seeing something by now. Have we had any issues with protons today? I haven't had a chance to look. Yeah, we went up to an S1 radiation storm when that shock wave went past us, and now we're beginning to go back down. So we'll see if it stays elevated over the next day or two as all the rest of these storms kind of filter through. Then it should settle down. It will settle down reasonably quickly within the next couple days. You bet, Adrian. Good to see you. We got red auroras. Go shoot. Get off the stream. Go shoot your auroras. They've got red auroras in Norway right now, which is just amazing. And they get that stuff with the north, even with the north directed magnetic field. Partially probably because there's a Y component, which I haven't even looked at. When you have Y components in the magnetic field, you can actually get some pretty good aurora too. Let's see. Yeah. Let me pop up the Y. Oh yeah, non-zero. Non-trivial. So, oh my goodness, right now? Yeah. Right now, am I standing in the way? No, let me stand over here. Right now, the blue is the Y component. That's the east-west component. Let me get my hand in the right place. You guys hopefully can see this. Right now, the Y component is almost 20 nanotesla, 18 to 20 nanotesla. So it's a very strong east-west component, which, believe it or not, actually energizes the Earth's magnetic shield. It energizes what we call the cross-tail current, and that actually helps that slingshot go. So right now, north, but the problem is it doesn't open the auroral oval. So what you have is really intense auroras with a small auroral oval. So places like Norway are going to see storm time aurora when no one else gets to see it because of that east-west current or that east-west field. So we may still see, and it also does still rattle the Earth shield. So, you can look for BY being big. If it's big, then yeah, you're definitely going to continue to see KP jump. So we may indeed see KP jump up to a G2, even if we don't get a lot of southward field. Let's go back to the home page. Has anyone checked to see? And nobody feel compelled to stay on here with me anymore. If you want to leave, feel free to leave. I can't figure out how to make this thing go away. How do I get out of this? No, we don't see anything yet. This is still, KP is still sitting at active conditions. Kind of behind the times, don't you think? That's the problem with a 3-hour index. And there's some real-time ones. I'm not going to go bother to look for real-time indices right at the moment for that. But I'll just go back to the sun. All right, guys, any other questions? You're very welcome, guys. I see all the thank yous again. Celebrate another day of living. Celebrate many more days of living. This is just weather, right? Just bring a big umbrella. Well, don't bring a clear umbrella so you can see through it and see the aurora, right? If you're an amateur radio operator, don't go up on your rig trying to figure out and troubleshoot. There's nothing wrong with your rig. It's just the weather, right? We're okay. Are we already in KP6? Yeah, it doesn't surprise me. Yeah, not with the Y component being as strong as it is, and the speed of the storm being as fast as it is. Doesn't surprise me at all. Are you doing FT8 on 40? It's actually, and it's live. You're not having problems? Okay, cool. And it's Tennessee, so it's dark there, isn't it? Isn't it nighttime there yet? But you're on 40, so you're probably fine. You'll be fine overnight. But it'll get a little weird for you, especially you get close to midnight. Is the physics of the sun the same as a plasma ball? No, not at all. Not even close. No, it's a radically different thing. I think if you look at some of my mini courses, we have a solar dynamo. This is a rotator It's a differential rotator that causes all sorts of different forces. I mean, it's a very complicated thing, not a plasma ball at all. And it's collisional. So it's very intensely collisional. Okay, guys, excellent. It looks like I've gotten most of your answers and questions and answers out of there. If we get a really bad storm, will it wipe out my Tesla? No. That's a good question, actually. No. The reason why solar storms cause issues for power grids is because power grids have an infrastructure that's hundreds of miles long. If your Tesla was 100 miles wide, then yeah, we could have a story. Okay, we could talk about it, right? You'd have to have a Tesla the size of Lake Michigan. Small devices don't have problems. Okay, this is not an EMP-like thing. What happens with, there are EMPs, but that's not relevant in this case. Once a solar storm gets underway, you're not really dealing with an EMP anymore. Solar storms, the EMP that actually we did get from this thing was actually at low latitudes, and it lasted for maybe 4 or 5 minutes. That was because of the impact. You actually saw that in that model, how the Earth's magnetic shield wiggled real fast. And that was over very quickly. But believe it or not, that affects low latitudes much more so than it affects high latitudes, because that's where the magnetic field is really strong at Earth. For mid-latitudes and whatnot, what we deal with are things called geomagnetically induced currents. And in order for those geomagnetically induced currents, due to the the Earth's magnetic shield wiggling, anything that wiggles in a magnetic field can get a current induced into it. And sadly, bedrock has conductivity, has iron, it's conductive. Rock oftentimes is. And depending upon the kind of rock, some are more conductive than others. Well, that means you can induce more current in them. But electricity doesn't like to flow through rocks, and it will look for wires if it can. So it will couple up into the electric systems. And so if you have these massively long cables, long wires, then you can get a good GIC, a good geomagnetically induced current induced in those lines. And the longer the line is, the bigger the current, because it covers more distance underneath this magnetic field that's wiggling. Okay, if you have something small, not a problem. If our power grids were only this big, this would never be an issue, because the Earth's magnetic shield is actually quite weak. It's about the strength of a fridge magnet, but it's a fridge magnet the size of Earth. So that's the difference. So don't worry about your Teslas. Don't worry about your computers. None of that stuff is a problem. If you get really worried about it, then just get a power conditioning unit, because you get brownouts or whatever. That's just normal, grid issues. But you're not going to have anything induced from the solar storm directly into your electronics. Please don't believe all that fear mongering, because it's just completely untrue. I don't care that the History Channel told you it would happen. It's wrong. It does not happen. Sadly, I was actually on a History Channel show, and they did that in the show, and I was so angry because I was trying to stop the fear mongering, and yet on the same show I was on, they showed a computer like exploding, and it was like, oh no, how dare them. Anyway, I got a long way to go. Okay, guys, we are magnetic electric water. That's not far from the truth. Biochemically, absolutely we are. That's why some people are electromagnetically sensitive to geomagnetic storms, because there's a lot of biochemistry, and those hypersensitive people can have issues. So those of you who are feeling malaise, those of you who are feeling tinnitus, hearing tinnitus, or your bones are aching, especially if you have metal poisoning in your blood, or if you have bone, plates or metal implants for whatever reason, those can cause issues for you. And this period of time during geomagnetic storms is you just have to ride it out, sadly. Yes, CMEs being a cannibal. Yes, cannibalizing CMEs. They don't really cannibalize. Actually, Nat Gopalswamy, who created the name cannibalizing of CMEs, they slam up into the back of each other. They don't really eat each other. Again, but that from that old point of view, that is what this would be considered, a cannibalizing CME that comes up and slams into the back of another one. And it really just becomes a composite event where you have two of them back to back. So that's why I think this is the beginning of something that we're going to see over the next day or two, because this is just the first of several. I don't know if the other one is quite as fast, because this is pretty fast. It does surprise me that we're seeing an 800 kilometer a second structure. So we're going to be paying attention over the next day or two and really watching it. You're hypersensitive, but no metal implants. Yeah, I know people who actually get on cell phones and they get rashes. They have to scratch their hands and stuff. All right, let me check really fast to see if anyone on Patreon has asked me questions, because I don't want to get off the stream without answering those questions. So bear with me. Oh my gosh, I've got lots. Is the CH James Dodonis says, is this the coronal hole high-speed stream contributing to? I don't. Oh, okay, I did answer. Yeah, I don't think so. Not in this case, but that was what happened with the Halloween storm. Lex asked me, since you pointed out the main CME that it hasn't hit, what do you expect when it hits? Goodness, Lex, I don't think. I just think more of the same. To be honest, I don't think it's going to be any worse than what we're seeing now. But this is pretty intense. Like I said, G3 is possible. I don't think we'll see a G4, but G3 is definitely possible with 800 kilometers a second. So we're going to be paying attention to this one, right? But if the field remains northward, then it's not going to be nearly as strong as all that. It could be a G2 though. Okay, Bart says, right now I'm working one U.S. station after another on FT8. Yes. Yeah, that's, if you're, especially on the day side, that'll be great. But FT8 is so robust, it can get through a lot of noise, right? FT8 and FT4 are just fantastic. Joe Taylor is just so savvy. When you said that a storm could extend to mid-latitudes, how far south do you mean? Again, that has to do with whether or not we have the southward field. But if we end up getting a G3, the best case scenario would be, oh my goodness, we could get Aurora down easily down to past Colorado, possibly, if we get a G3. We could have Aurora easily through Indiana. I'd be careful. Southern Ohio, definitely into Iowa, maybe even South Iowa, northern to mid California. So we're even talking about going past south, further south in Oregon. We'll definitely, if we get G3, as far as the Aurora Australis, we'd get Aurora that comes up not just New Zealand and Tasmania, but also in Victoria, possibly even Perth. The last time we had a G3, I saw Aurora pictures from Perth, Australia, so it was really nice. But it's just so hard to say, especially when I'm seeing so much northward field right now. But this is early on in the storm. We're not seeing the core of this thing yet, and I'm not even sure this particular storm that we're seeing right now is the one that is, the direct hit. This could still be the grazing passage from the one that was in front. Hard to say. Hopefully that answers that question as best I can. Matthew, you say, thank you for showing where these derived from and their trajectories. Oh, thank you, Matthew. That is so awesome. Explanations are pure gold and information invaluable. Can Aurora ever get down to 32 degrees north latitude? Sure, absolutely it can. Does a lot. And you will see that more and more often. History channels know more about real history. Yeah, tell me about it. Oh, man, if you guys ever want to laugh, watch the Doomsday series on History Channel and look for the one that's called Solar Storms. I think it was called Solar Storms. It was, I don't remember what episode 4 maybe. Oh, goodness gracious me. Yes, I'm on it. And there were certain questions I wouldn't answer on purpose. And so they ended up getting Michu Kaku, I can't pronounce his name. They got him to answer them instead. And this theoretical physicist is trying to answer questions about, space weather. And he's so wrong. He's just so wrong. It's just not even funny. But, the guy's supposedly an expert on everything, right? You put physics in the title of your name and everybody thinks you know everything. Oh, whatever. Physicists. Can't live with them, can't shoot them. Wait, I'm talking about me. No, anyway, it's just very frustrating. Oh, good morning, Deepak. It's good to see you. Sadly, I'm just about to get off this stream, but good morning in Jakarta, in Indonesia. I love seeing you here. My favorite episode is the one where Earth stops rotating for no reason. Oh, I don't even know where to start with that one. That kind of stuff is just like, it's just nuts. It's like, or when the moon decides to suddenly just go ram straight into Earth. Like, what are you guys talking about? Why are you doing this? The problem is that you get experts, right, who have a lot of letters behind their names, and they talk this way. And so people believe them. So to be honest, it's actually, to me, they do more damage that way than the ones who are just conspiracy theorists and YouTubers who don't have the credentials. Because when you put the credentials behind someone's name and they do this ridiculously wacky stuff, everybody takes it for gospel. And I think it's so irresponsible, right? Know the limits of your expertise. You don't see me talking astrophysics. You don't see me talking terrestrial weather. I am neither of those, right? I am a space weather person. And even when I get into areas in space weather, like the ionosphere, for example, or deep into the sun, into the solar interior, you see me balk, right? I kind of slow down and say, I can speculate maybe, but it's speculation because I don't know for sure because it's not my expertise, right? You will not see me step outside because I'm very humble when it comes to knowing that a physicist doesn't know everything. A physicist knows a very small part of physics. and they need there's not enough people who remember that when they especially when they start become science communicators, because they get asked questions and they just want to be able to answer them. But oftentimes their helpful answers end up being damaging because they don't realize how much credibility people give them. And a lot of times they don't deserve it. So not all physicists, but some. Let's see. Oh, moving too fast. Is there a relationship between solar storms and earthquakes? Oh my goodness. I answer that question so much, I will not answer it now. Go to any of my mini courses and that question comes up constantly. It's a very difficult question to answer because we don't have enough information from the geophysicists. They have not answered things well enough for us to be able to, as space physicists, to get any quantitative answers or any quantitative analysis. It's all speculation. But I don't dismiss it. It's just we can't answer that question. And people need to understand mainstream science can't answer questions that they can't attack from a quantitative fashion, in a robust fashion. They have to wait. So, okay. Oh, does it? Is Jen, you're saying the BZ might be going south again? Okay, cool. Here we go. Game on, guys. Or as the Aurora community says, pants on. I quit physics because my professor advisor thought your ideas were witchcraft. Ugh. You know, yeah, I'm sorry. That's I hate that stuff. There's a lot of empire building, and people look at things the wrong way. Oh, thank you, Liam. I saw what you said about my something about my generosity or my generousness, not generousness, my genuine self. I do try to be genuine. If you met me in person, this is exactly what I'm like. So I don't put on airs. Oh, good. Thank you, Patrick. Yeah, I try to be honest, and I'll get things wrong. I got things wrong with the Halloween storm. I'll get things wrong again. So, definitely keep on top of me, and I appreciate the pelting with olives because it helps keep me honest. You need a geophysicist too. Yeah, I see that, Chuck. I know the feeling. I wish the geophysicist could solve the earthquake tectonics issue, because then there are a lot of space physicists who would love to jump on this, because someone would get the Nobel Prize. If you could link space weather to earthquakes in a robust quantitative fashion, I guarantee you'd get the Nobel Prize. So trust me, there's lots of physicists who'd love to be able to tackle that problem, but every time they tackle it, they go, ugh, the thing I'm trying to measure, the error is as large as the thing I'm trying to measure. I can't make any sense of it. So nothing will be accepted in a peer-reviewed publication about that stuff. We're just not ready yet. Okay, guys, I think, yeah, Dutch is a great guy. I like Dutch since he's doing some really interesting work, and he's a French scientist who needs to continue doing it, because French science, as I've said many times, pushes the envelope of mainstream science. Mainstream science has a tendency to get calcified, and so we need French scientists out there pushing the envelope for us to show us what is possible to work on, and give us interesting ideas. But then again, mainstream science needs to kind of rein in the speculation of French science. Otherwise, they float off into the cosmos and we never see them again, and they're not grounded in reality. So it's this really nice give and take, and we all need to play nice. It's not one against the other. It's the left hand and the right hand, and we need to shake each other's hand and help each other instead of fighting so much. Right? That's my personal opinion. Okay, guys. Any advice for a heliophysicist and space weather minor student? Any advice? Yeah, stay in this community. It's going to become very important, and learn as much as you can from social media, from credible sources. There's lots of us scientists now, especially on Twitter, and more of us are coming online every day because they're seeing what we're doing, and they're getting excited about it, because there's a lot more citizen science. There's a lot more awareness. And funding is loosening up and becoming more available to people who do work with the public. So stay on this cutting edge, and befriend us, talk to us behind the scenes, learn as much as you can, because there's so much to be learned, kind of like on the job training, and you'll learn so much more doing that you will not learn in an academic setting. Just talk to any of my students; they'll tell you. Okay, guys. Thanks so much. Jerry is saying, thank you, Tamitha. I think that's his hint to, you're done, get off. I need to go eat dinner. and yeah, it's time to go take a look at the storm, guys, especially if that field is turning southward again. So good luck Aurora hunting, and good luck FT8ing for you amateur radio operators if you do that. FT8 and FT4 are probably the really good ones to be on tonight. But yeah, expect some fun in the magic band. 6 meters, 10 meters should be fun. Auroral propagation will definitely be active, and just be patient, right? Because we during the evening hours, because we do have disruptions on the night side. And if you're a drone flyer or a GPS user, be careful, especially on the night side and any place near Aurora. Okay, guys. So I will say goodbye, and I thank you so much, and talk to you soon.